Hi, this is Chris Love, and this is the first of perf audits. And this is where I'm going to go through and analyze different websites for web performance optimization issues. And tonight, I'm going to start with Red Dress Boutique. And this is a site that I did a quick perf audit on my blog back in mid-May. The site was brought to my attention because it was on Shark Tank. The owners of Red Dress Boutique made a deal with Mark Cuban, and he's invested in their company, and their business has been growing because of that. But I was kind of brought to focus on this site from a performance point of view because they were featured on one of the After the Tank episodes, and that's an episode where the Shark Tank production company follows up with companies that were featured in the actual Shark Tank to see what's going on with the company now. And each one of them has some sort of dilemma that they had to overcome. And in the segment that featured Red Dress Boutique, the owners were set on building a new website for their company because they didn't feel like it was really scaling and performing correctly for the amount of traffic that they're getting. Now, I know enough about the size of this site just from doing enough websites over the year that I'm pretty comfortable saying that I could probably make it run and run pretty efficiently on a single server. And where most of their performance issues are going to be in the front end, because this is very common. This is why I want to do these perf audits. And if you're not familiar with the Web Performance Golden Rule, Steve Souders created this back in the 2007-2008 timeframe. And effectively, what he stated back then was that 80% of your web performance optimization issues are in the front end and not the server side. And back to the episode that they were featured in, Mark Cuban kind of pushed back, telling them that he didn't think they really needed a website, that his guys could do it. Now, I think they're using kind of a third-party e-commerce infrastructure to do it. I'm not sure off the top of my head which one it was. They never did say. I think I figured it out at one point. But the real issues is it just had a lot of low-hanging fruit. Now, what you're seeing right now is not the exact same site that I went through and analyzed back in mid-May. They have made some improvements. In particular, the two items that I kind of wrote about in my quick audit back in May, we'll let this pop back up, was they had a really high speed index, and I'll talk to you about what speed index is, and they had a really poor time to first byte, and that effectively means that it took a long time for the server to render the markup. And this is a very common issue, and what happens here is the request is sent to the server, and because most of our pages are dynamic, meaning that there's a lot of uh, things that have to go on to kind of get the data to render the markup, it takes a while to make database calls and things like that. And honestly, it shouldn't, even if you're making calls to SQL Server, for example, this stuff shouldn't really take that long. And the way to get around this is to properly use server-side caching. And if you're coming from an ASP.NET world like me, that means you've got output caching implemented. And that means that the web server process effectively caches the rendered content for a designated amount of time. And with ASP.NET output caching, you can actually vary by query string parameters, by languages, and various other aspects of the request, so that you've got a very nicely cached static set of content that needs to get sent down to the browser or the client. And when you've got that set up, the server doesn't need to do any processing, and it's effectively as if you had just a static web page that was being served. And web servers are very efficient at serving just static content. And so you rarely see any significant time to first byte delays. So that's effectively what's going on. The other thing that I pointed out is that they aren't bundling and minifying content, and I'll show you how that affects it here in a minute. And they're kind of violating the cardinal rule of CSS in the head and scripts at the bottom. I believe that is, yeah, that's pretty much what I pointed out. Now what I'm going to do is we're going to go look at some web page test runs that I did. I did one this morning, and just to let you know that I'm recording this in August 20th. Obviously, you can see this on my clock down there. So this is the one that I ran back in May. And if you are familiar with web page test, this is a synthetic testing tool, and it allows you to just go to webpagetest.org, put in a URL, and then you can select the browser that you want to have it tested in, as well as one of their various data centers around the world. This is very nice because it allows you to kind of see how your page is loaded in different browsers and different locations, and see how the different latencies and things like that can affect it. Now, I just ran this over typical home broadband cable internet and used Internet Explorer 11 for this particular one, and that's going to give us enough information to get a pretty good idea of what's going on. So real quick, up here at the top is kind of the scorecards, just some quick visuals to kind of let you know if your site's doing good or not. This one I would say is doing on the bad side. So time to first byte, which I pointed out is F. They do have keep alives enabled, and they did do Gzip compression. I see that avoided a lot, unfortunately. They're not doing a good job of compressing their images, and we'll talk about that, as well as caching static content. And I'm also going to say, even though it says it's got an effective use of CDN, I'm going to say that they are not effectively using a CDN. We'll see how that plays in. Now the next little section down here is just some metrics about the site. The one in particular I'm going to pay attention to is the speed index. And this is a metric that Patrick Meehan created, and he's the person who created webpagetest.org. And the simple definition of it is it's the area under the curve. And when I say that, what he's doing is he's got intelligence built into web page test to effectively measure how much of the page has been rendered over the course of time. And what you really want is you want the bulk of the page rendered as fast as possible. Now, where does this come from? Well, he's got this film strip view, and this is a very valuable view of how your page renders, so you kind of can see what's going on. Now, if you actually load a page, you'll feel this. Now, you notice it went straight to 6 seconds, because if you look at this at 5.5 seconds, there's nothing rendered, and at 6 seconds we finally get some stuff rendered. And I'll go back to that waterfall, and we'll see there's some events triggering that coincide with this, so there's actually other ways to measure this as well. What the logic that Patrick built in is kind of looking at, okay, we've got nothing but white, nothing but white, nothing but white. Now we're starting to get some actual content rendered in it, and it keeps going until it's fully rendered. As you can see, this just takes some time to render. Now, it's an application that I've built. You see this is going from 5.5 to 6, so 5, 5.5, 6. So these are half-minute or half-second intervals. That's very broad. Typically, when I measure a site that I've built, we're looking at 1/10 of a second intervals, because it usually renders within a second or second and a half. So what it does is it breaks it down in smaller increments. And so you can see it in a little more granular mode because this takes so long. Now notice down here at the bottom, we've got a little bit of the waterfall, and this is not my preferred view of the waterfall, but there's this red line right here. And as I go through it, it's matching up time. So you can actually see where we're getting our first paint events. So we'll look at the actual waterfall, and we'll see how this matches up. And to me, it makes more sense looking at the other waterfall. But you can see there's a big gap right here, right on that widgets.js, and that's a third-party script right there. But and we'll see that here in a minute, a little more detail on that. But I really like this film strip view. This is a great way to kind of visualize it. If you want to just grab that, you can click that link, and it'll export the entire film strip as one image. And that's very useful if you're trying to put together reports or visualizations for management or just your development team to grok. All right, so I'm going to go back to, let's go back the page to our main summary here. As you can see, the site's not necessarily optimized for perf either, but that's okay, we'll deal with it. So this main area right here, this main visual that we have, this is the waterfall. Okay, and this effectively gives you a visual of how the page loads all the resources needed to compose the page that's rendered for our customer. And I'm going to click on the waterfall, and we're going to go look at some details here. Up here at the top, we're going to have a little legend. Well, it's not a little necessarily, but sorry, it's taking a little bit longer. I notice when I do like recordings or do PowerPoint kind of stuff, is the graphics don't work so great on this. It seems like so. Anywho, so these different color codes kind of tell you what's going on this chart here. These are events that start render in this MS First Paint, and then you've got the Don Content Loaded event, the onload event, and document complete. They all kind of tell you different aspects of what's going on, but the waterfall is usually, I can usually glance at a waterfall and I can pick out quite a few things that are wrong without even digging into the detail. And obviously the first thing that I pointed out was time to first byte. So if we go click this initial request for markup, sorry, I clicked the wrong one evidently. Here we go. All right, that's what we're looking for. You can see right here the time to first byte is basically 1300 milliseconds, so that's 1.3 seconds. Now, you want that to be as close to nothing as possible. Now, the first piece of that, and this is something that's overlooked a lot by developers and architects and IT pros, is the DNS lookup. Now, this is the time it takes to resolve where redaddressboutique.com, for example, goes to, what IP address that goes to. And this is actually a good time. I see many sites, and I've been into many Fortune 100 and 500 companies where their DNS lookup is a quarter second to even as much as a half second. And that's pretty deadly because nothing's even hitting your server for that first 300 to 500 milliseconds. So you want that resolution to be done quickly. Now, Azure and Amazon Web Services both have DNS hosting, and they're both really fast, and they're both super cheap. So we're talking, I think it's a quarter per domain per month, maybe 50 cents. I can't remember which, but somewhere in that ballpark. Folks, that's next to nothing to have really good DNS resolution. There are other services out there that at least claim to be in the 10 to 20 millisecond range consistently, which is super lightning fast. So it doesn't take a whole lot to have a good DNS server to make that resolution happen quickly, and that's very important. Now, their real problem is the fact that this taking forever for the server side to actually compose the markup to get sent down. Now, again, I believe they're doing an ASP.NET base with some third-party e-commerce CMS, and I imagine it just doesn't have, it's just not configured correctly at this point. This is something they seem to have corrected on the latest run, and let's just go look at that real quick so that you can see the difference. So I'm going to bring up a run that I did this morning with a slightly newer site, and you can see that their time to first byte, we see first byte, which is the second column here, is basically 0.2 seconds. So that's within acceptable range right there, and that's what we want to see. So this is something that they fixed, and I did make several runs back in May just to kind of verify that, and I kept seeing the same consistent problem there. Now the reality is the browser doesn't start requesting anything else till it gets that first thing of markup, because that's got all the links to our CSS and the script references to JavaScripts and images and possibly even custom fonts. And so none of that stuff can even start happening until the markup is actually in the browser, so that the browser can parse it out. So that's why you want to have this as quick as possible. Now, another thing that you want to try to do as much as you can, this is why Gzip Compression can be extremely valuable, is you want to try to get as much of your markup and even your CSS it down to the browser as quickly as possible. And the way TCP works is the first packet is 16 kilobytes. Now that first packet has 2 kilobytes of metadata or overhead with the response headers. And so you really only have 14 kilobytes for your data. Generally, for any web page, you shouldn't have so much markup that you can't hit that 14 kilobyte goal, so that first packet comes down extremely fast, because the way TCP works is what we call slow start. So you get the first little packet or bucket of data comes across is 16K, and the next one comes down as 32K, and then 64K, and so. But if you get that 16K, that's just one quick round trip, and so that happens extremely fast. Now, to let you know, I can build 70, 100-page single-page applications, and I can easily fit all my markup in that 14 kilobyte packet with the initial CSS inlined in the head so that it renders extremely quickly. So don't let that intimidate you that you don't think you can do that, especially when you've got Gzip compression turned on. You should easily be able to hit that even with a rather large single page application. All right, so let's keep looking at what's going on here. Now, I noted that they weren't doing bundling minification. So you see here, there's a lot of CSS files, and then we got a lot of JavaScript files, and this is a common problem that I see. Now, these are static files, and the web server is serving these up individually relatively quickly, but if they would bundle these together, let's just say they bundled these CSS files, they would probably get these down in probably the amount of time it takes to download this particular one right here. This is only 1 kilobyte, but notice, oh wait, that one's, I hit the wrong one again, folks. This one's 20 kilobytes, but notice it's 136 milliseconds. This first one is 1.9 kilobytes. So this is a lot of wasted overhead. So this is 16 kilobytes that has to come down, even though the packet is 1.9 kilobytes. So if we were putting that together, and let's just see if we have a response. It is gzipped. All right, so if we packed all this together, basically we would be, I would say we're probably going to be down, probably this 155. That would probably be more or less what it would take to download all of those combined. Now, let me tell you about the way the connections to the server work. The way the spec's actually written, the browsers are only supposed to open 2 connections to a particular domain. Now, the de facto standard that the browsers have chosen to implement is 6 simultaneous connections. So that means we can't get enough stuff through the pipeline, basically. And when it talks about effective use of CDN, this is not really effective use of CDN. These static files, the CSS, the JavaScript, and the images, those should all be offloaded to a CDN. Again, Azure and Amazon both have great CDN offerings, and they're both extremely cheap. Even when I've got my most traffic months, which is probably about 500,000 uniques in a particular month, my max that I've ever paid for my image hosting was about a quarter. So CDN hosting in the cloud is super cheap these days, and it's just something you shouldn't cut out. It's easy to do and execute. You can even automate the deployment process to it. So I would bundle these up, especially make sure they're minified as well, and put them on a CDN. And that CDN is also going to distribute them closer to the people who are going to be trying to download it, and that just reduces your latency again. All right. The other thing about CSS, if you've got a lot of CSS, you probably aren't using much of it. I run all my sites through a node module called uncss. It was created by Adi Asamadi. There are grunt and gulp task or plugins that you can use to execute this against your site. And what it'll do is it looks at your pages and produces the CSS file that contains all the CSS rules that are applied and used on a particular page. And for example, Audi ran this against a bunch of sites running Bootstrap and found that they typically use between 10 and 12% of Bootstrap, for example. And Bootstrap's a really large CSS framework, but most sites rarely use hardly any of it. So that's a lot of weight that has to get downloaded. So effectively, you're just spamming the internet and you're causing your customers to render slower. So actually having one file with the actual CSS you're going to use is a best practice. And it's not hard to do, especially with the task runners we have these days. Now, next one, we've got a lot of JavaScript, again, bundling and minifying this. And this is something I see a lot because a lot of people just throw jQuery in and then they throw about 20 plugins. Very rarely do they really even use all these plugins. It's just kind of the developers just have a stock set that they use half the time, and they just throw them in there. They think they might use it, and they don't. Or you use fast food frameworks like Angular and React and Ember, and you use very little of those libraries as well. And then there's all the modules and plugins and stuff in those ecosystems, and it gets out of hand, to be honest with you. And again, if you just bundled those files together, you would have a single request. That single request would come across the wire a whole lot faster. Now, the next thing about script files that's unique is they're blocking requests. That means that the browser stops everything it's doing until that JavaScript file is downloaded and evaluated by the browser, because it has to determine if it changes the integrity of the DOM, and if it does, it kind of has to start everything back over again. All right. So this is another reason why you want to have just one file to evaluate, and you want to have it as small as possible. You may not see it on your powerful desktop as much, but if you try to load it on your typical Android device or say an iPhone 4, you're going to feel the effect of trying to evaluate that script. It's going to be enhanced. So if you've got say 10 milliseconds on your super powerful desktop, on your iPhone 4, that's probably going to be more like 60 to 70 milliseconds just to evaluate the script and everything. Plus it downloads slower, especially over GPRS. And so you want to try to avoid that as much as possible. So you can see here we've got jQuery lazy. Who knows how much bandwidth. This is a pretty large one here. Okay, so this is 1.9 kilobytes, but notice it took 100 milliseconds, so that's bad. And that's coming from a third party. So you want to try to avoid third parties as much as you can. So this is Form.js. This is probably a jQuery form plugin. 3.8 kilobytes, 6.9 kilobytes. This is the slider, 3.3 kilobytes. See, all these are really small files. These could easily be bundled together and loaded a whole lot faster, a lot more efficiently. Now the other thing too is you notice nothing's rendered yet. We got all the JavaScripts loaded, nothing's rendered, but then we're hung on this widgets JS file, which looks like it's something to do with the Amazon payment stuff. Now I can guarantee you, I feel pretty confident that this is for the shopping cart part, the actual buyer making a purchase thing. I can guarantee you it's not relevant for the home page at all. So even if this was a single page application, I would lazy load this script in and somehow cache the content locally. Of course, this is coming from a third party, so it gets a little more dicey about you controlling the caching of it. But I would definitely not load this as part of my mainstream. This file in particular is holding up everything else. Let me just close this out. Now, as you notice, basically this gets loaded. It has to get evaluated. This is why there's a little gap right in here. So this file gets evaluated. Once it gets evaluated, it starts trying to download images. So this is the header image. Let's see if we got, yeah, there we go. So that's the actual header. That is really long. It's 2.1 seconds to get the header image in. So if we look at the details, I want to see how big that one is. That's 560 kilobytes. I guarantee you that file can be optimized. And I bet it's probably bigger than it needs to be. There we go. I'm going to run it through my favorite image compression service, which is kraken.io. I want to show you how this works. There we go. Now I have a paid account, but they do offer what I'm going to do for free up to a certain amount. I think we'll see how long this is going to take. Of course, things go slower when I'm recording. All right, so we're going to go to the web interface. Yada yada yada. Sorry, folks. The graphics when I'm recording do take longer. All right, here we go. I'm just going to paste the URL in there and make it quick. I guarantee that header can be optimized quite a bit. Of course, this is from May, so let's see if it's the same image. Okay, so the original size is 300 kilobytes, and they reduced almost half of it and didn't actually change the integrity of that header. Let's see if it's the, yeah, it looks like it's the same image. So you could just get that, and it does look like it's bigger than it needs to be, in just my opinion. I don't know, it may not be. Oh yeah, because it's, yeah, we're expanded a little bit. They're a little bit bigger than they should be. If we go back over to the site, let's see if they're still using it. They're not using that header anymore, so that's actually good. But that is an example of having unoptimized images and you can see that that is taking a long time to download that image. Now that tells me that the images are not really done. Now this is a really small one, I can tell, 3.8 kilobytes, and it's a small image sprite. And I bet if we went to the next one, that's just one of their models. This is another image sprite. I would combine these little tiny image sprites together as much as possible. Yeah, and then we're back down to, that's a third party. That's a debug.js. That's kind of scary for me to see that there. This looks like it's just a tracking one. Body.png. So this is just a 1 kilobyte image. I hate when I see that kind of thing. Yeah, so they got a lot of really tiny images. Let's see what this one is. Just a line. Yeah, they could definitely make some differences there and make this better, reduce the number of images. Now they're going to have a lot of product images, obviously, but again, I want to point out that they're not using the CDN for this, so it's not quite as efficient. So this is 3.9 kilobytes. Again, probably should just be part of a big sprite. Just one image. They could probably get one sprite image, probably 50 to 60 kilobytes at most to cover pretty much all their needs. This is kind of ballparking it based on my personal observations of different sites over the years. Anyway, so they've got a lot of images. See this robotics-tops is it's requesting something that's just not a normal URL. It's not even valid. So that's 404. That's just delaying things a little bit. They're not really caching much, which is another bad thing. There's no expires headers on a lot of this, and that also want to make sure you got set up. So if we go look at the response here, we don't have an expires header that I can see. They are using Varnish, which is a caching mechanism, if I remember right. And this is coming from Nginx, which is interesting because looking at the effective use of cache, I believe we see some requests to ASP.NET HTTP handlers, which is kind of old school ways of doing ASP.NET stuff. Today we actually use Web API to do a lot of the stuff that I've used HTTP handlers for. It's going to bounce us down. I'll get to look at all the files that do not have expires headers set on them, and so you can see there's a lot. And like I said, this is this is the third party using the HTTP handler, so that's why it's not part of there. So they're using Nginx, so they've probably got it's PHP or backend. Just it says 8 hours is what the expires is on that one. Generally, for especially things like images that don't really change, set those things like 12 to 24 months into the future. If you really think they're going to change, you can always do some cache busting mechanisms on them, but just try to set that as far out as possible. That way you make sure it gets cached and the browser hangs on to it. Now, a little caveat to that, mobile devices purge their browser cache much more aggressively than desktop, and this is because they just don't have the amount of disk space, right? So the browser algorithms will purge that stuff much more frequently on phones and tablets because you're looking at 16, 32, 64 gigs of storage. I've got an iPad 2 with 16 gigs, and the Monopoly game alone that my kids play has got 2 gigs of it taken up. So there's really not a whole lot of space left, and I'm constantly being told I'm out of. I'm just going to kind of wrap it up at this point because I think we've kind of covered just about everything. But real quick, let's just go look at the web page test that I did run this morning, and just kind of see that the render was cut in half, and that's good. Now it's at 3 seconds, and that's still a critical point right there. Just to let you know, if your page is not rendered and effectively perceived as usable by your visitor within 3 seconds, you're going to lose half the traffic. They're just going to hit the back button and go to a competitor, or they're going to type in an address or something different, because the human mind actually starts fading away mentally from something after 1 second. And this is psychology stuff. So if you actually look into how the brain works and stuff like that, 1 second is when the mind starts to wander. When I say wonder, I mean wander is really what I should be saying, emphasizing the A there, and go mentally start going on to something else. And so at 3 seconds, what we're seeing, what traffic and sites are reporting, it's effectively half the people have moved on to something else. So that's something that's critical. So they're right at 3 seconds. So they're still wasting some valuable time there. Now the site itself still takes almost 10 seconds to actually render. Again, we want to try to update as much as possible. Their waterfall is not as tall. It is more bytes now. They're using um, kind of the sliding hero image stuff here. And we're just going to kind of bounce into their waterfall here. All right, so they did fix their time to first byte. They still have a pretty vertical drop off, and that's actually what you want to see on a waterfall until you get about halfway down here where it starts being wonky and going sideways. Again, they've got some unoptimized images. If we go look at this one that takes 6 seconds to download, we'll see that this is probably pretty big. And again, I can probably, I think I did run this one through a little earlier through Kraken. I think I was able to get half of it cut down. Oh, come on. Sorry about this. This happens when I'm recording again. There we go. Yeah, we're pretty close to 600 kilobytes. I think I got it down to 260, 270 kilobytes is what I got it down to. Again, saving a lot of bandwidth. The other side of it too is make sure your images are sized appropriately for how they're going to be rendered. So anyway, these are common low-hanging fruit that every site can fix. They don't take a lot of effort, and they don't take much money. Seriously, the CDN hosting and the DNS stuff, you're probably looking at 50 cents a month, ballpark, 50 to 60 cents a month for most sites. That's nothing if it helps you get that one extra sale. I mean, seriously, one extra sale should cover it. And I guarantee you, you will get that one extra conversion that you're looking for, just because the science that we have behind this proves that out. So I want to encourage you to start tackling some of these low-hanging fruits. I'm going to start posting more perf audits here at the YouTube channel, and I'll try to have an accompanying blog post on my blog. If you have a site that you want me to review, feel free to ping me over Twitter, and that is at Chris Love. And follow my blog for some of these perf audits. It's lovetodev.com. That's LOVE, the number 2, DEV. And just again, give me some feedback, leave comments below, and thanks for taking some time to examine these perf audits. Thanks a lot.